Well, I'm trying to start again. Can you hear me? But nobody. Well, I see no reply. Okay. Okay, now I can start. Well, I'm Dmitry Kochergin, head of technical support department of Rakurs company, and I'm glad to announce a new webinar. Today we will talk about, the previous webinar was dedicated to radiometry of satellite imagery, and now we'll talk about actually geometry of satellite imagery. And the topic is satellite imagery block adjustment and PHOTOMOD system. Basically, we'll talk about push broom imagery, but as you can see, you can read from this slide, there are some exceptions. For example, Canopus B sensor, Russian sensor with compound matrix, and some old generations of Landsat satellites. But as I already said, we'll talk basically about push broom scanners, push broom sensors. And the idea is to talk about the input resolution of satellite imagery, input conditions of the survey, and the accuracy of output products, like, first of all, ortho, mosaic, or digital elevation models. As again you can read from the slide that the block adjustment is a refinement of geometrical model of satellite images of source exterior orientation data. We'll take a look on a couple of samples of Spot 5 and GeoEye, and as usually I will show the presentation and from time to time switch to PHOTOMOD system itself. Well, we support several methods of satellite images adjustment. The first, it depends on the data that we can take from the satellite operator. And in case if you know all information about the model of sensor, we use rigorous method. In this case, we know everything about orbit location coordinates, exterior orientation parameters, and in case of RPC, we have an information about rational polynomial coefficients, which make the dependence between image pixel coordinates and corresponding terrain coordinates. And the last case, very seldom case actually, is generic, when we have no information about sensor. And then we can use this method, taking into account only that we deal with the push broom geometry of the image. Two types of survey. Monosurvey. Monosurvey is just a set of images taken from different angles, taken from different sensors in different times. The idea is to cover some surface of the Earth by images having no overlaps. And the final purpose is orthomosaic, and if we have some digital elevation model taken from outside. Stereo survey is more complicated thing. It is a survey with usually about 90% overlap, and what is very important, optimal intersection angle. The angle of survey, the angle of intersection or convergence angle. We will talk about it later. And the final task in this case, of course, DTM creation and high quality orthomosaic. So again, this is an illustration to monoblock. Set of images with small percent of overlap usually, and usually this kind of survey is used for kind of small scale of output products like 25,000 or maybe 10,000, 50,000. In this case we use various sensor, various time, various number of channels, various survey angles. Everything is kind of arbitrary. Stereo. We can say that in this case the output product can be an orthomosaic up to 2000 scale, but it is in very perfect condition. Usually it's up to 5000, and we also make an accurate DTM, and because we have stereo pairs. And in this case, of course, we use one sensor, one time, and equal number of channels of source images. Usually this survey produces stereo pairs from one track, from one orbit. Groups, it's a kind of combination, because sometimes operators of the scanner imagery systems provide images divided artificially into some parts, into fragments. So we can see that this one orbit, it's another orbit or track, this is third one, but the customer got these pieces of total cover of the surface. And in this case, PHOTOMOD can be used for grouping the images. So finally we have one image like this, one image like this, and one image like this. And the idea is to use less ground control points and to make faster block adjustment, and the requirements to increase the requirements for the memory. Of course, you have to measure tie points to make the groups of patchworks of these images. Now, kind of steps of satellite imagery processing. We have to split our images into strips. We have to measure tie points, and of course we have to filter some blunders, some errors in our measurements. And splitting into strips, when you split the block into strips, you have to follow some rules that you can see on this picture. In stereo block, you have to put every stereo pair in a separate strip. Monoblock is kind of more complicated structure. If you have images from different sensors, you have again to put each image in separate strips. In case of one sensor, you have to take into account you have to take into account different orbits or one orbit or tracks. And again, in this case, you use the option split by metadata, and in this case, you again put every image in separate strip. Enter. Tie points. The purpose actually is clear. First of all, we need tie points to make the block adjustment, to make actually the triangulation of satellite images, in order to calculate new exterior orientation parameters which are more accurate in comparison with the source ones. Then, as I said before, sometimes we can use grouping of images by using tie points. Also, the tie points help us to decrease the search area while building digital elevation model. It makes the process much faster. And of course, we need tie points for stereo pair formation. Actually, it's not obligatory thing for stereo blocks, because in this case you make stereo pairs immediately after loading images. But anyway, tie points can help us to make better orientation of the source images in the stereo pair. This is a lot of parameters that you are using when start automatic tie point measurements. Well, for those of you who knows the PHOTOMOD interface, they are basically clear, but I will show you the place in PHOTOMOD where actually you should set them up. So I switch to some project, and this is our automatic tie point measurement button. And I will not start this process, but all of those parameters are here, like correlation threshold, measure tie points only between strips, relative orientation and the completion, using the DTM, which again will help us with tie point measurements, and some more parameters are over here, like matrix half size and so on. So we can just compare this slide with the PHOTOMOD and find the proper place in PHOTOMOD to be used for setting up these parameters. Next, some steps of type points filtering, removing the blunders. Yes, the problems with an accuracy of type point measurement almost always occur on the monoblocks, because the images in monoblocks came from very different sources, different resolution, different sensors, different angles, so they look different, and the correlator sometimes have getting into the troubles in measurement. So the correlator makes some mistakes, some errors, and we have to remove them, to filter the points. And the filtering is also divided into 2 steps, like blunders, about 50 pixels, and the rest of errors. Now, several words about the geometry of the survey. As you can see here, for example, one satellite position, another one satellite position. One picture, actually another picture. And DTM also has an error in relation with the true ground. So there are 2 components of error, actually, DTM and the angle of survey. Usually the name of this angle is off-nadir angle. So we have alpha 1 and alpha 2, 2 off-nadir angles. They form 2 errors on the images, delta S1 and delta S2. Actually, it is a multiplying of the DTM error on tangents of the angle. Also, we have the relative error, which in this case is kind of subtraction. So sometimes absolute error is bigger than the relative one. In some cases, the relative error is bigger. And we actually have to take into account all of them. So this error is responsible for correct coordinates, actually, on the final product. And this error is responsible for coincidence of the outlines of the objects on the ortho mosaic. So it's the first case, like subtraction. The convergence angle look like that. And something is wrong with my enter. And another case is another intersection. You see from here, and in this case, the relative error is bigger than any of absolute ones, because it is not minus over here, but plus. But the idea is the same, that you can calculate preliminary error, relative and absolute error of the output product, if you know these angles. And based on that, we can calculate actually which angle can be used to achieve the output product of predefined accuracy. We can consider, for example, SRTM model as digital elevation model, and for different kind of angles, we can calculate which output scale we can reach after the processing. So as you can see, for 5000, we have to have very nadir aerial survey. Otherwise, you are not able to use SRTM, but you have to use some digital elevation, more accurate digital elevation model, and so on. And we take into account that SRTM accuracy itself is about plus minus 10 meters for plane areas and about, well, plus minus 40 meters for the mountains. And now I'll go back. I will switch again to PHOTOMOD, show a small sample of using different digital elevation models and how they affect the accuracy. Well, first DEM is, as I said, SRTM. It looks like this. Another one is the DTM calculated in PHOTOMOD for the same project. Create a new layer. And you see that even visually it looks much more accurate. I will zoom it in. And another DEM is a difference between them that was also calculated in PHOTOMOD. This is new layer. And this is a DEM of difference. And if we will estimate, if we will analyze the difference DEM, we can see that in the plane areas the difference is kind of small, couple of meters, but on the ridges and on the splits of relief, it's about like 30 meters, 40 meters, and so on, so on. So in these places, this RTM is not enough for some output tasks. And another tool that can immediately illustrate the problems that can be produced by the DEM of low accuracy is as we call it, fast ortho. I can build fast ortho by using SRTM, and I can build fast ortho by using PHOTOMOD DEM. So rasters, create fast ortho layer for first image, rasters, create fast ortho layer for the second image, and then I can use a tool, layer view mask. Where is it? Here it is. I can move this slider, and I can zoom in my picture. I can actually make one by one zoom. And I can analyze actually the cut line between these two images and see how it actually be seen on the ortho product. We see some displacement in this case. If I make the same thing with more precise DTM, again DEM load, DEM PHOTOMOD in this case, and again where is it? Fast ortho, first, fast ortho, second, window, layer view mask, come on, see it somewhere here in the overlap area, make zoom one by one, and see that now the situation is better. Okay, so this is about different accuracy of source digital elevation models. Next, again, is very important, because we are talking about two steps of filtering errors caused by filtering bad type points. All of these parameters are in PHOTOMOD solver, actually. So on the first step, we turn off using type points in the block adjustment, and we turn off the refinement at all. So we adjust the block taking into account only source RPC coefficients, only source metadata, only source exterior orientation parameters. And on this step, we can easily see and remove very big errors, blunders. Well, approximately like more 50 pixels or something like this. As soon as we remove these big errors, we can make the next step for final refinement, for final bad type point filtering. And in this case, we use this option. Now we use type points, and now we select some method of the refinement. Well, usually bias is enough. And also, this option is very interesting and important. We can load the digital elevation model into solver, and it can be used for blocks, for monoblocks, which has very small intersection angle. I will talk about it right now in some more details. Well, final block adjustment. Let's see, everything is okay with our type points, and now we have to make ground control point measurement. We can make groups if we need them. We can also make the block adjustment step by step. It is kind of new option in PHOTOMOD. We will not talk about it in details. We'll make the final adjustment. The idea of step by step is when you have some images in the block, adjust them, and you want to keep the results of this adjustment when you add some new images in the block. So this is the idea, that the previous one will be in the correct position for sure. They don't change their positions in orthophoto, they don't change the exterior orientation parameters, and so on. Well, a bit about number of ground control points. Of course, it's very typical question. Of course, you will see this presentation. You can load this presentation after webinar, so I just show it. Well, 4, 6 points for different kind of sensors for rigorous method. 1, 4, or 4, 5 for RPC method for different sensors again. Also some information about checkpoints and the type points, like 3, 4 in double overlap area, 3, 4 in quadruple overlap area, and so on. Well, and generic method requires much more ground control points, so of course it's better to deal with RPC or rigorous models. And more detailed options in solver for refinement. 4 ground control points. You can use bias and drift option. 1 ground control point, of course, only bias, because there is no way to make any more complicated transformation. For rigorous method, like resource decay, Russian satellite, 8 ground control points. You can use these options: refinement along and across track 1, refinement for all, yaw 1. And for Formosat, for example, like that, just samples. This is about final adjustment. Actually, options are the same, like it was on the step of second step of type point filtering. And again, use DEM. We will talk about it a bit later in details. When you should use DEM, when you should not use DEM. Interesting how to control the errors and how to control the complicated situations with the intersection of convergence angle. So for small intersection angle, like 3 degrees, which is very typical for monoblocks, you will see, you will calculate the error on type points. But the height value for them can be incorrect because the task is not really reliable because of this small angle. But if the angle is relatively good, like 15%, everything is basically fine with the accuracy control and with the calculate height of the type points. And similar approach for the accuracy control on the, I am sorry by the way, I will go back to this slide. Now we are talking about image tabbed page on solver here, and here on the model tabbed page. Again, in this case, you don't have reliable decision of the mathematician task, because the accuracy of z for small intersection angle is very low. So this value is not reliable. So you should not believe it, should not trust it, because again of this intersection angle. And everything is basically fine if intersection angle is correct, like in a stereo survey or in some cases of mono survey. Well, again, I'm going back to PHOTOMOD and open another sample. Now it is monoblock of spot images, and we have some type points in there, and we can start solver. And set up the parameters. Now we do not use digital elevation model. We have RPC over here, we have bias, and we don't use groups. Everything seems to be okay. Compute. And we see some errors on the ground, on the type points. And also we can estimate the height values. The height for these points, in strip points, which has very, very small intersection angle, is like 5, for example. But these red points calculated between strips, and the intersection angle is better, and the z value is more correct. How can I actually estimate which one is correct, which one is not correct? I can go back here and load some DEM. For example, it is Aster DEM. I should display my type points over, and actually I can even hide my DEM and start the procedure which called check DEM against the adjustment points. And you can see I can sort the points by z error, and all small z errors correspond to red points, to violet points, to magenta points. Well, and I'll go to the end of list. All big errors will correspond to the yellow points. Yellow points are measured in strip. Magenta points are measured between strips. But as soon as I load a digital elevation model to solver, I will get another result. So again, I click the parameters and I say, well, use DEM. Aster. Okay. Compute. Save. Now the coordinates of my type points are recalculated. And again, if I start the same procedure, I will see that now, well, first of all, EZ is almost 0 because I use a digital elevation model. I can also estimate that all points now have, well, proper Z coordinate, no matter whether it is yellow or magenta. So this is a sample how to use digital elevation model in Solver. If you have small intersection angle, small convergence angle, the digital elevation model can really help you. But usual question, whether should I or you use digital elevation model all the time? Actually, again, it's not, there is no one answer for this, because it depends. I'm going back to the first project, and this project has good enough intersection angle between these two images. And as we told before, we have several DMs, right? We have SRTM DM, which is not accurate enough. We have a DM calculated in PHOTOMOD, which is better. And now we can see how the behavior of the PHOTOMOD solver in case of using the first one and in case of using the second one. Solver parameters. Well, first, I don't use a DM. Okay, compute. I have errors like this on type points. So I don't use DM now, but I have a good intersection angle. Now I use, where is my too big window? Okay, now I use good DM, calculated in PHOTOMOD, for example. Okay, compute. The errors is bigger, but it's still not so bad. And finally, I use, sorry about this window, SRTM DM, which has not enough accuracy. Okay. And I have the picture like this. So the errors on type points is bigger. So you have to use DM only in case of small intersection angle. Shouldn't use DM, for example, in stereo blocks. Shouldn't use DM in monoblocks with the good convergence. So also a couple of words for groups. When you use groups in Solver, you have to act as following. Of course, I have to group these two images. I have to group these three images. I have to group these two images, and I have to select them in the parameters. So I can say, well, these two images form first group, these three images form second group, these two images form the third group. It can be done manually, it can be done automatically in some cases, depending on the metadata. And it's not very interesting sample because the adjustment will be approximately like without groups, but for big blocks of images, it really helps. It really helps to have good connection between two images here, and it takes not so much time for the block adjustment. Well, save. Go back to my presentation, but in fact, it's almost done. I have only 2 pictures more. The first one about this tool, layer mask or shutter, and another picture about how to control the adjustment by using the digital elevation mode loaded into the PHOTOMOD montage desktop. So I am basically done with my webinar, and of course I am waiting for questions. No questions? 2 days ago, you make the same webinar for Russian customers. You had a lot of questions. So, my friends from Rakurs have some doubts. They ask me, maybe just nobody took part in the webinar, but I can tell you that we have at least 11 people in the attendee list. So it's not true. You have attenders. Maybe something was wrong with the, I don't know, with the sound, but nobody actually complained about it during my perfect and nice presentation. Yes, sound is okay. Well, of course, everything will be available on our website. I mean, the webinar itself, the video with webinar and the presentation separately. And of course, you can contact us by email. Maybe you will get some questions later after viewing this presentation or viewing the webinar. Also, another suggestion from my colleagues. Today we have published a new build of PHOTOMOD 5241503, and so we can load it from our website. There are some new features, some new interesting features in there. For example, step-by-step adjustment that I announced, and some radiometry thing that we announced in the previous webinar, like using quick look for radiometric correction. Also, I can invite you to Rakurs conference. We have a conference this September, and this time it will be in France, as far as I know, not far from Fontainebleau, and not really far from Paris. So I think, as usually, it will be in a very interesting and nice place. Even Vanya Petrova has no questions. It's unbelievable. Vanya, ask me something. Hi, Dima. Hi, Vanya. Okay, anyway, it was very nice to see you here. We really like our customers. So, they always, well, I have some messages that will get the questions by email. Yes, sometimes, of course, it's more convenient. Some big questions, some special data, so on, so on. Sometimes it's not easy to reply in online, of course. Why you use DLT? Why you use DLT? Actually, not only DLT, there are several methods of generic sub-methods of generic method. When? Sorry, sorry, I can't read that. Sorry. We use DLT, when we use generic method of adjustment. Actually, there are two generic methods, as far as I remember, parallel perspective and DLT. And I can ask our, experts, but I think that you can use one of them and see when the results is better. But again, as I said, generic method is not really usable, because now it was popular maybe 7-8 years ago, when some sensors when we did not know information of some sensors like Indian IRS, as far as I remember. Now all data are accompanied with RPC coefficients, so I don't see any reason to use generic method. I think RPC is much more popular and better, because it does not require so many ground control points and so on. Hi, Filipa. Very nice to see you also. Hi to all friends and records. DLT on UAV. UAV is a central projection, so we don't use DLT. But again, I can ask, for example, Peter Titerov, maybe he has some idea in this case. But UAV is a central projection, so we don't need to use DLT method. Okay, probably I can. Thank you, Yanis. I can finish, because I don't see any more questions. But I think when we will load it, and when you take more precise look on the presentation, you will send us some questions. And actually, we are going to make some more detailed material on this theme, because it's very interesting to know all these details about satellite imagery, block adjustment. Because last time we have very complicated projects in records, very kind of difficult projects, because data came from different time, from different sensors, from different angles, and so on, and hundreds of images. So the geometry should be taken into account precisely. Okay, so I think I'm going to finish. Thank you for the attention, but I'm still waiting for the questions via the email. Stop. Where is it? How can I finish? Yes, and Thank you one more time.